In this video, we're going to look at probabilities that involve the word or. So remember back in set theory, we had this formula for cardinality that said the number of elements in A union B was the number of elements in A plus the number of elements in B minus the number of elements in their intersection. Well, hopefully your answer is yes, you remember that, because we're going to do something really similar. Now we're going to have the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So these formulas are really similar. The difference really is I changed the first letter. In cardinality, I talked about the number of elements. In probability, I talk about how likely they are to happen. What we're really doing in both of these is just taking out that double occurrence. Anytime something happens twice, we don't want to count it twice, we only want to count it once. So we have to just take out that intersection. Intersection and meaning the same thing. So let's take a look at some examples and see how that plays out in probability. A little different than set theory, but I just wanted to, make your brain think of, hey, here's not really a new formula, it's something I know already. All right, so let's take an easy first example and say we have the spinner below. And I wanted to find out the probability that I land on red or I land on an odd number if I spin the spinner one time. So let's use the formula I just gave you, which would say the probability of red or odd would be the probability of red plus the probability of odd minus the probability of being both red and odd. All right, so red, I have 1 out of the 6 slices is red, so I have 1/6. And then odd, I have 1, 3, and 5, so there are 3 out of the 6 choices that are odd. We do want to notice that the red slice has an odd number, so I've counted it twice already, so I just want to take out that one time that it happens both times. Okay, add that together, the 1/6s cancel out, and I'm left with 3/6, and I just want to reduce that to 1/2. All right, so let's stick with that spinner and just change what we look for. So this time, let's look at the probability of getting a green or an even number. Okay, so again, let's go back to that formula. So green or even, I would have probability of green plus probability of even minus the probability of both green and even. Okay, so the green, 1 green, so 1/6 of a probability that I'll get a green slice. Even, I have 2, 4, and 6, so that's 3/6. But green and even doesn't happen, so we're just going to put in 0 there. All right. So 1/6 plus 3/6 gives me 4/6, and again, I want to reduce that, so it gives me 2/3. Okay, notice this time we don't have an intersection. I didn't have green and even, so I put a 0 there. Just wanted to give you this other word, actually a phrase. When two events cannot occur at the same time, we call them mutually exclusive. Just saying, it's no big deal if they don't happen together. We have that 0 probability of them happening, and then we have a term to refer to that saying they're mutually exclusive, they won't happen at the same time. Okay, so let's change the way we do it. Instead of a spinner, let's go to a chart and say I had a survey where I asked 400 people to pick their favorite, so just one sport, and their responses are summarized in this table. So the sports that were offered were football, soccer, basketball, baseball, or hockey. And then just how many people chose each of the sports is listed on the right. All right, so let's look at our first question. It says, find the probability that a person's favorite sport is basketball or baseball. Okay. So basketball, we can see 87 people prefer basketball out of the 400. And then baseball, I had 45 people out of the 400. There is no intersection, so I didn't put anything there. There's not a choice where they got to pick 2. So I just had 87 plus 45 is 132 over 400. This time I decided let's do some percents because I think our brains wrap around percentages better than we do fractions a lot of times. So I just want to show you that that is 33%. And a little side note that, again, the events are mutually exclusive. Respondents had to pick one sport to be their favorite, so they couldn't say basketball and baseball. Okay, so I'm going to stick with that chart and just ask a different question. And this time I said, find the probability that a person's favorite sport is not football. Okay, because football is just one category and I had a bunch of categories, it's really easier to subtract the number of people who do prefer football from the total than it is to add up all the people who don't prefer football. All right, if that didn't make sense, here's what I'm doing. I know I have 400 people, that's what it says up here. I also know 168 people prefer football, which means the rest, the 63, 87, 45, and 37, I could get just by subtracting 168 from 400 and say that's 232 that didn't pick football first. All right, so that says my probability of not preferring football would be 232 over 400, which gave me 58%. All right. So how about you try one? Here is another chart. This time I made it a survey of 250 students, and I said, let's look at whether they go to school full-time or part-time and whether they have a job or not. And if they do have a job, do they work full-time, part-time, or they don't work at all? So take a second, try this one out where I'm asking you a few questions. I start with just tell me probability that they're a full-time student. Tell me also probability that they work full-time. Then I said find the probability that they're a full-time student and they work full-time. And then lastly, find the probability they're a full-time student or they work full-time. So pause the video, give yourself some time to answer these 4 questions, and then return to the video so we can just check your answers together. All right, so let's go over those answers. All right, so let's start with full-time student. So full-time student, I'm looking across this row, and I can see I have a total of 91 students over the 250 total. Okay, working full-time, I want to go down this column to see I had a total of 59 students working full-time, again, out of the 250 total. Full-time student and work full-time, busy people, right? So here's work, here's full-time student. I had 14 out of the 250 people. And I put these all together using our formula to find out OR. So OR says, if I'm trying to find full-time student or work full-time, I could go back to probability of full-time work student plus probability of full-time working minus both, right? So I set up an order for us, and that says I get 136 over 250. Absolutely, you could do this a different way, where you just kind of went through and picked up the students from there, where you wouldn't have to subtract them, where you could just go full-time student or working. Okay, here's my working, and then my full-time student, and you could have added those up. That's fine. So there's multiple ways to get the right answer. Any way that you get the right answer is awesome. So I'm happy with either of the choices for you.